Aha!
Good morning, everyone. Am I audible? Okay, so I am audible. Good morning. Okay. So how many students have joined? 26. Where are the rest? Total, I think 38, 39 students are there, right? So 10 students are less. Okay, no problem. Um, okay, so today we will start our class. Let me share my screen. Is my screen audible to, sorry, it is visible to you? Please mention in the chat box. Okay, okay. Okay, so everyone has got your syllabus that day Sapam has given, I have seen. So, seeing the syllabus, you can note there, you can see that there is like only the treatment part. Yes, treatment of one is your treatment of water, and the other one is your treatment of wastewater. Okay, so now after studying in your fifth semester environmental engineering, now you were quite clear, okay, what you have to now study. Yes, so here the previous part, like the water demand part, okay, like why water is needed for domestic, industrial, so all those things now it is not needed to explain to you because you already know why water is important. Okay, what are the demands of water, so all these things you know. So now since it is an elective subject, we have to learn the broader aspect of your the treatment of water and the treatment of wastewater. Okay, so now first in your syllabus, the first thing that it was the characteristics of water. Already we have done it, but then also we have to revise it. Okay, so like for the characteristics of water, what are the how many characteristics of water are there? Can anybody tell me? One is already shown in the slide, it's in the page, it's already shown. One is your physical characteristics. Yes, one is your physical characteristics, then the second one is your chemical characteristics, and number three is your biological characteristics. Okay, three characteristics are there for your water. Okay, like similarly for wastewater also the same characteristics are there, but that one we will study after completing your water treatment part. Okay, so now for the raw water, okay, it can be analyzed by how, by studying the physical, chemical and the microscopical or the biological characteristics of water. Okay, so now in your physical characteristics, what is done? So in your physical characteristics, the physical analysis of water is carried out. Okay, here the physical analysis, that means there are physical tests. Okay, some physical tests are carried out to determine how much of this physical characteristics of waters are there. Okay, so what are the physical characteristics? There are like five physical characteristics. Number one is your turbidity, okay, then your color, okay, then taste and odor, okay, then temperature and your specific conductivity. So there are five physical characteristics of water. Okay, so now we will come to turbidity. So what is turbidity? So suppose in a glass of water, okay, in a glass of water, I have mixed some clay or some like suspended matter. I am mixing it like clay, or it is silt, or some any other organic materials I am mixing in a pure glass of water. So how will that glass of water look like? Obviously it will be like, it will be not aesthetic in appearance, isn't it? It is, you, if I give you to drink that a glass of water, obviously no one will drink that. Yes, because we always drink a very clean and clear water. Those are like, it is it is pleasant to our eye, okay, and we know that that water is clear. But by looking that glass of water in which the suspended matter, or the this where there is no, you are looking the water, it is not clear, okay, something is there, you know. Okay, so that thing is your, that term, what you will tell, that term is turbidity. Okay, so turbidity is what, if you know, in like a large amount of, you can say, like suspended matters. Okay, suspended matters like what, it's clay, silt, okay, it may be clay, it may be silt, or it may be any other organic materials that can be present in water. Since you are taking the water from a source, like you are taking the water from lake, you are taking the water from ponds, you are taking the water from wells, okay, so when you are taking a water from a source, you will not get a clear and clean water, obviously. Okay, so there will be, there obviously there will be some organic matters, or there will be some suspended matters present in that water, and that water will look very muddy. Okay, that water will look very muddy, or you can say it will look very turbid in appearance. Okay, so that turbidity, like you have to measure, because you have to these organic matters, okay, these suspended matters or the suspended particles that are present in that water, obviously it will not be very harmful to your health, it will not be harmful to your health, you can drink that water, but they have to be removed or reduced. For what? For aesthetic and your some reasons, it have to be removed so that you can drink it. Okay, so now this here the definitions, I will give this PDF format to you in the group. Okay, you take out the important points and you can write it down. Okay, so here it's written here, you see. Wait, let me annotate it. You see here. Okay, so how to annotate, how to annotate. It's not coming. Okay, no problem. Okay. So here you can see, okay, this first line you see, this turbidity, this line you see, if a large amount of suspended matter such as clay, silt, or some other finely divided organic materials are present in water, then it will appear to be muddy or cloudy or turbid in appearance. This one already I told. Okay, so this turbidity, it depends upon the fineness and concentration of particles present in water. Obviously, if there are more amount of suspended matter, if there is more amount of organic materials in that water, so obviously that will appear more turbid. Okay, it will be more cloudy in appearance, it will be more turbid in appearance. Okay, so although this clay or these inert suspended particles, they are not harmful to health, but they have to be removed or reduced for your aesthetic and psychological reasons. Okay, so now it's written that since people, they do not like turbid water, so the turbidity of raw water, it must have to be measured. Yes, fine. So people, obviously they will not like turbid water. They need a clean and clear water. So this water, this turbidity, it have to be measured and it has to be reduced. Okay, so that it is, it is almost invisible to your naked eye. Okay, so it has to be reduced to some permissible limits, because though it is not possible to remove 100% of turbidity, but then also we have to reduce it to some permissible limits so that it becomes invisible to your human naked eye. Okay, so this turbidity, how it is measured? It is measured by a instrument, or it's a apparatus, you can say. It is measured by a turbidity rod. Okay, it is measured by a turbidity rod, or you can say it is also known as a turbidimeter. Okay, scientific term is what? Starbidimeter. So a turbidity rod or turbidity meter is used for measuring the turbidity. And how it is expressed? It is expressed as the amount of suspended matter in milligram per liter, or ppm. So what is ppm? Parts per million. If you can remember your last class, like in your fifth semester, ppm is what? Parts per million, or same thing, milligram per liter. Don't get confused these two terms. Okay, these are same term. ppm, milligram per liter, means what? ppm, parts per million. Okay, so now the standard unit. Okay, what is the standard unit of your turbidity? Okay, so the standard unit is that, okay, which is produced by 1 milligram of finely divided silica in 1 liter of distilled water. That means you are taking 1 liter of distilled water, okay, and in that 1 liter of distilled water you are adding 1 milligram of silica. Okay, 1 milligram of silica. So that 1 milligram of silica plus 1 liter of distilled water is your standard unit of turbidity. Okay, so a turbidity, like in if it's crossing 5 units, okay, if it's crossing 5 milligram per liter or 5 ppm, so that means it is easily detectable in a glass of water. Okay, and what it is written, turbidity in a clear lake water is about 25 units. So in a clear lake water it is 25 units. So you can remember this, you have to remember these values. Okay, you later you note it down. So in a clear lake of water it is about 25 units, and for muddy water it exceeds 100 units. Okay, for muddy water it exceeds 100 units. And for uh, the permissible, okay, if you want to this permissible turbidity, how much of limit should be there for drinking water? Okay, so that is the permissible limit is 5 to 10 milligram per liter of turbidity for drinking water, as suggested by the health department. Okay, so 5 to 10 milligram per liter is your permissible limit for your turbidity. Clear? Okay, so now next is your, like we will be discussing about the turbidity rod. Okay, so turbidity rod, you see this is the diagram of your turbidity rod. Okay, so here what it is written, the turbidity, it can be easily measured in the field with the help of a turbidity rod. As I already said, for the field purpose your turbidity rod is used. Okay, and for your like in your lab, or in your if experiments are to be done in the lab, so there are more three types of rods. Okay, or you can say some turbidity meters are there. We will come later. So now the turbidity rod, it what it consists of, what is this rod, this total rod made up of? It is made up of what? It is made up of aluminium rod. Okay, this is a aluminium rod which is graduated. You can see some this part, you can see it is graduated. Okay, what is the unit? The unit is silica units. Okay, in silica units that is milligram per liter, it is graduated. Okay, so to the upper end of this rod is attached a graduated non-stretchable tape. So here is a, you can see here this part, it is here, it is a graduated non-stretchable tape. Okay, so as to help in lowering the rod. So when you will lower the rod, this graduated tape will help you to lower the rod. Okay, so then a screw containing a platinum needle and a nickel ring is inserted at the lower end of the rod as shown. So at the bottom of your rod, okay, a graduated, a platinum needle is there. You can see this is a platinum needle. What is the diameter? The diameter is 1 millimeter diameter. And what is the length? Length is your 25 millimeter long. Okay, and there is a nickel ring present. Okay, so the standard platinum needle is 1 millimeter in diameter and 25 long, already mentioned. So a vertical rod or a stick is inserted in the nickel ring so as to support and keep the rod in vertical position. Okay, this one is just to keep this needle in vertical position, for that it's written. Okay, so now in order to, how will you now measure with this turbidity rod? So this, in order to measure the turbidity, the graduated, this aluminum rod, it is lowered in your turbid water sample. Okay, you will put the this turbidity rod in the this your turbid water sample. Okay, so and you will keep your eye at the top. Okay, here it's written eye mark, so at the top you will keep your eye. Okay, vertically you will keep your eye there. So now what's written there? You see, uh, the submerged needle is viewed. Okay, so when you keep your eye above and you are putting the rod, you are dipping the rod in the water sample and you are watching your how much turbidity is there. Okay, so like at a point when you are lowering slowly, you are moving this rod downward. So there will be a time when this needle, it will be invisible to you. Okay, the rod, it will become or it will just disappear. You will not be able to see the needle anymore. Okay, so that is the point you will, in the graduated scale, you will see the reading. Okay, how much of turbidity is present there. Okay, so that is the like process by how you use the turbidity rod. Okay, so it's written that the lesser the length, the greater is the turbidity, and vice versa. Obviously, the if you are dipping the this rod, okay, and there is only like lesser length is available at the top, so that means more turbidity is there. Okay, so this is the way how you measure the turbidity using with the help of a turbidity rod. Okay, now coming to this is one of the fill method. Okay, fill method is your, by using turbidity rod or a turbidimeter, you are measuring the turbidity. Okay, now coming to turbidimeters. Okay, so we for like for laboratory, in the laboratory you use the like turbidity, you use turbidimeters to measure the turbidity. Okay, so now there are two types of turbidimeters. One is your Jackson's turbidimeter and the other one is your Bailey's turbidimeter. Okay, two types of turbidimeters are there. So what is Jackson's turbidimeter? You know, like in a Jackson's turbidimeter, it is also known as what? Jackson's candle turbidimeter. Okay, so the main thing is that the Jackson's turbidimeter, it ranges, this turbidimeters, it can measure the turbidity up to a certain range of turbidity. Okay, so if the water sample is, like it is turbid up to the range of 25 to 1000 milligram per liter. Okay, if the turbidity in the water sample, it ranges from 25 to 1000 milligram per liter, then you can say that you can use Jackson's turbidimeter. Okay, so now you will see the process of the Jackson's turbidimeter. So this is your, actually no, it's not needed, but then also I just want to explain. So you can see this is the actual the right hand side photo view of Jackson's candle turbidimeter. It is the actual view, and this is the section through it is a sectional diagram. Okay, so here you can see that here it is a graduated glass tube. Okay, it is here, it is a, at the above there is a graduated glass tube. Okay, now then below that there is a tube holder. Okay, there is a tube holder, like into which you can just put the glass tube there. Okay, so now and below that tube holder, it's a stand, it's a stand. Okay, metallic stand, and below the metallic stand there is one candle. Okay, there is one lighting candle. So now if you here it's a like slit, you can the candle, the flame of the candle, it can be watched by, if you put your eye above the graduated glass tube, you can watch the flame of the candle. Okay, so it's like that, the metallic stand is made like that. Okay, so now if you, when the glass tube is empty, you can see the flame of the candle directly. Okay, but now what we will do, we will put the turbid water in the glass tube. Okay, we will keep on pouring the turbid water in the glass tube. Now after slowly pouring, you are pouring the turbid water, at a one time will come when you will be no longer be able to see the flame of the candle. Okay, you will no longer see the flame of the candle. At that time you just stop pouring the water, and you read the graduated scale. Okay, you read the graduated scale, that is, in the water glass, this tube. Okay, glass tube. So that is your turbidity measured. Okay, that amount of turbidity is present in the water sample. Okay, so this is just a simple experiment. This is a Jackson's turbidimeter. So main thing is that Jackson's turbidimeter, it can measure turbidity up to the range of 25 to 1000 milligram per liter or ppm. Okay, this is the important thing. Okay, now next is your Bailey's. Okay, Bailey's turbidimeter. So Bailey's turbidimeter, it is your it can measure turbidities in the range of what, 0 to 10 milligram per liter. So this if our drinking water, you can say drinking water, this Bailey's turbidimeter can measure. Okay, but Jackson, it cannot measure because it is from 25 to 1000. So our drinking water, it doesn't contain so much of turbidity. So 0 to 10 milligram turbidity, a Bailey's turbidimeter, it can measure your drinking water. Okay, so now this one no need to explain. This one is certain type of experiment is there. Experiments are not needed, but then also, okay, next is your okay, the next is your Nephelometer. Okay, one commercial turbidimeter is there. This is a Nephelometer, is your modern, you can say modern commercial turbidimeter. So Nephelometer is there. So in Nephelometer, okay, wait. Okay, so Nephelometer, yes. So here, like the unit for Nephelometers is that it is Nephelometric Turbidity Unit. Okay, in short, it is known as NTU, Nephelometric Turbidity Unit. Okay, and also similarly to nephelometric turbidity unit, one more unit is there, FTU is what? Formazine turbidity unit. Okay, so why the name is here FTU formazine? Because here formazine polymer is used. Okay, so that's why it is known as your formazine turbidity unit. Okay, so this is all about your this turbidity. Okay, so now next is your color. The next physical characteristics is color. So why color? Why color? You can see the water as colored water, because the dissolved organic matter, what is written here, dissolved organic matter from decaying vegetation or some inorganic materials such as colored soils, etc., may impart color to the water. So what imparts color to the water? Like you can say that dissolved organic matter from the decaying vegetation, or you can say any other inorganic materials such as colored soils. Okay, so that imparts color to the water. So again, if like in the water there is excessive growth of algae or any other aquatic microorganisms, that may also impart color to the water. Okay, so what it's written that this presence of color, it is not objectionable. Obviously it is not objectionable from it will not cause harm to you, but it may, like it will obviously spoil the color. If you wash clothes with a colored water, it will obviously spoil the color of your clothes. Yes, and also it is not it is not suitable for any, from any aesthetic and psychological point of view. Okay, because if anyone gives you the to drink a colored water, obviously you will put some objections and you will not drink that water. Yes, so now how the color, it's obviously the color, it is a physical characteristics because we can see that with our naked eye. Yes, so like we can measure the color by like a with the help of a comparison method. Okay, so there are some standard glass tubes. Okay, there are some how to measure color actually. So there are some standard glass tubes. Okay, and that standard glass tubes, it is known as your Nessler's tube. Okay, so in that tube, in that standard glass tube, they contain solutions of different standard colors. Okay, of different standard color intensities they are uh, they contain. Okay, so whatever sample you have, okay, with you, so you have to compare your color with that standard Nestler tube. Okay, in which color is it's going on. Okay, it's similar, so you have to check the comparison. Okay, similarly we the standard unit of turbidity was what? The standard unit of turbidity was like 1 milligram of silica in 1 liter of distilled water. So similarly for color also we have the standard unit of color is what? It is 1 milligram of platinum cobalt. Okay, here it is not silica, it is platinum cobalt dissolved in 1 liter of distilled water. Okay, so like if you have different color intensities like 1 ppm, 2 milligram per liter, 3 ppm. Okay, so you can be easily dissolve it with like 1 milligram of platinum cobalt. Okay, if it's 2 ppm, then you take 2 milligram of platinum cobalt and you dissolve it in, or you mix it in 1 liter of distilled water. Okay, so what is the permissible limit for your domestic supplies? The permissible limit for your for color, okay, for domestic supplies is 20 ppm. Okay, so it is 20 ppm. And for you can say for precise, okay, for some precise determination of color intensities, of small color intensities, there is also one instrument which is known as your tintometer. Okay, tintometer. So that instrument is used for some precise like color in the, to measure color intensities. Okay, and now for the public supplies, okay, for the public supplies, the color number on the Cobalt scale, it should not exceed 20 and it should preferably be less than 10. Okay, so 10 to 20 is the permissible limit for your color intensities for public supplies. Clear? Okay, now coming to the third this physical characteristic, that is your taste and odor. Now, why this taste odor, or why this how this taste it comes from, why it comes from, okay, why it occurs. So if the dissolved organic materials, okay, or the inorganic salts or the dissolved gases, okay, if the dissolved gas or dissolved organic matter or if inorganic salts are present in water, then it will impart taste and odor to the water. Okay, taste and odor, these are coming simultaneously. If taste is, if odor is there, then taste is also there. Okay, if taste is there, then odor is also there. So these are occurring together. Okay, so like, okay, the meeting will end in 5 minutes. Oh, if the meeting ends, you join once again. Okay. Okay. So this taste and odor. Yes, I am talking about. Oh, yes, this taste and odor. Why it? How it occurs? It occurs due to the presence of some dissolved gases. Okay. It occurs due to the presence of some dissolved gases. Like what? It is like hydrogen sulfide gas, you know, okay, hydrogen sulfide, then methane, then carbon dioxide, then oxygen, etc. Okay, if these dissolved gases are combined with any organic matter, okay, and if the mineral substances like what, sodium chloride, iron compounds, okay, carbonates and sulfates of other elements, okay, so if these things are there, or if any oily matters, or if any phenols are there, so all this leads to what, this leads to the occurrence of taste and odor. Okay, so for drinking, okay, if you want to drink a water, obviously this water, it must not contain any undesirable, or it must not contain any objectionable taste and odor. Yes, it should be odorless, it should be tasteless. Our drinking water is tasteless, isn't it? So if it contains some taste and odor, now obviously we, our work is to remove the taste and odor from the odor sample or from the raw water. Okay, so how to, you know, how this taste and odor it is measured. Okay, so the taste and odor, it is measured, you know, by a term or a terminology, you can say, that is your odor intensity, or it is also known as your threshold odor number. Clear? It is also known as your threshold odor number. So what is threshold odor number? You are taking, suppose in a beaker, okay, there is a sample of odor sample. Okay, one sample of water is there which is very odory, which is very you know, smelly. Okay, so you are taking that odor sample, suppose it is 40 milliliter. Okay, suppose you are taking 40 milliliter of a ordered sample. Okay, now you are adding, okay, you are adding diluted water, or sorry, you are adding the distilled water to that ordinary sample of water so that you make it odorless. Okay, so in that beaker where there is the odor sample, you keep on pouring your distilled water till the time the water sample it gets odorless. Okay, so that moment, okay, that time at which that odor sample it becomes odor free. Okay, so that is known as your threshold odor number. Is it clear to you? That is your threshold order number. Okay, so now uh, one small not numerical, but it's you have to know. Okay, um, okay, let us do one thing. You leave this meeting and you join again, because again I will explain, then it will again the link will expire. So you do one thing, you leave this meeting and you then rejoin again. Okay, everyone?